Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about Java String. All code examples used in the videos will be available on GitHub. Let's get started.
So first point is that a string, it's a class in Java. It's an inbuilt class in Java. Okay, it is a class Java, inbuilt class in Java string. Okay. Now, in which package this class exists? This class is defined in the default package. It's defined in the default package, that is java.lang.star package. Now, the string means we say it's a sequence of character or collection of character. As we know, right, string means we always defined it as collection of character. Collection of character. That is a string, you can say. Collection of character is defined as a string. Fine. So if I'm going to define a string, so what I'll do, I'm just saying a string s1 equal to collection of character like hello. I can define a string like this. This is one type of declaration of a string. This type of string declaration is called, if you remember this, it has a particular name for this type of declaration. It is called string literals. String literals. String s1 equal to hello. I've declared one string. This type of declaration is called a string literals. I can define the same string like this way also. String s2 equal to new string, and here I'm writing here hello. This is also a string declaration. This is also one type of string declaration, and you are nothing but you are creating a string class object, and this is a string constructor. You are passing the argument to create an object of a string, that is s2. So this type of declaration is called dynamic declaration. Right? Now, in these two types of declaration, we can create a string that is said to be as a collections of character. Okay. Okay. Now, string has one property. The name of the property is immutability property. Immutable property. The string is called immutable. So what is this immutable property? Immutable, we say that a string is immutable. Immutable means, so you know what does it mean by immutable property? Okay, so we say another one property for a string, number 4, is that a string is immutable. What does it mean by immutable? Immutable means once created cannot be changed. Immutable property means once created cannot be changed. So what does it mean by that? Once created cannot be changed. Now see, I'm creating on a string s1. So string s1 equal to hello. This is one string. Fine. This is one string. Now what I'm doing is that I'm just writing here s1 dot concat s1 dot concat. I'm going to add another one string with this, that is world. What happened done? Actual string is hello. Now I have added another concatenator, another string called world. So what I have done, this string s1 I have changed and made it s1, and you can identify this as an string. So I have changed that string, right? Earlier it was hello. Now I have concatenated one string world with s1. So it will be hello world. So I have changed this s1, right? Right. So now I'm saying that string is immutable. Immutable means once created cannot be changed. I have created one string and I have changed it. So both contradicts. Correct. Once again I'm saying string has a particular property that is called immutable property. Immutable property means once created cannot be changed. So in this example, I have created one string object, and using this concat function, I have changed that string to hello world. Correct. So both contradict itself, right? So no, it is not contradicting actually. Just you have to see here how it is created in the memory location. When I'm creating S1, S1 is the name of the string. And this S1 has a particular address. Assume it is 1, 2, 3, 4. In hexadecimal, this address will come. Oh, right? Okay. Now this S1, whom it is pointing? It is pointing to a particular object. Name of the object is hello. This object created in the heap, and this object also has a particular address. This object also has a particular address, and name of the address, assume it is 7, 8, 9, 10, 6. And this reference is pointing out to this object. So how? Because this reference contain 7, 8, and 9, 6. This address. This S1 reference contain this address. That's why S1 is pointing out to this object. 1, 2, 3, 4 is an address of S1. S1 is pointing out to this hello object created in the heap. It has some address. Assume it is the address. So when I say that S1 is pointing out to this object, that means this address should be available inside S1. Then only S1 can pointing out this object. Fine. Okay. Now next time when you have created s1.concat hello, what happened? When you have written s1.concat hello, when you have created, so it is creating another object called hello world. So another one object created in the heap, assume its name is hello world. Hello world. Right. You can write here s1 equal to s1.concat like this. So what happened in this line? What happened in this line? Now this is an hello world created. Fine. So hello world, this object that is created, it has some address. Assume this address is this. Assume it is this. Assume. So this hello world object has some address. Hello world object has some address. Fine. Now who is pointing out to this hello world object? S1. S1 equal to s1.concat. Hello world object created. Now S1 is pointing out to this object hello world. Right? So now this, it is not printing to this anymore. It is not pointing out to this object anymore. So this S1 Since I'm using a notepad approach, so I'm just showing you like this. And now here, now S1 is pointing out to this object. Now S1 is not pointing out to this object anymore. Correct? So in this line, when I'm using S1 equal to S1.concat world, then S1 is not at all pointing out to this object hello. Now S1 is pointing out to this object hello world, and it's a new object. It's a new object that created, right? So what happened to this object? Here, this object is unchanged. You are not changing this object at all. You are creating a new object, right? And this object, since S1 is not pointing out to this object anymore, it becomes an unused object in the heap. So that's why you have written here that string is immutable. Once created, cannot be changed. If I create a string, you cannot change that string. If you want to change it, it is going to create a new string. You are not changing the existing string. It is already there in the heap as an unused object. Since S1 is not pointing out to this object anymore, so in that case, it will change, right? It will be 3555 because it is pointing out to this object, right? So that's why we define like S1 is this is the property of immutability property of a string. Okay, once created cannot be changed. If I create a string object, I cannot change that one. If you want to change, it will get a new object every time. Okay. Okay, so this is all about string immutable property. It's a important property. Fine. Okay. Next point is that I have one string object hello. Now see here, two string declaration we have used here. See, one is called string dynamic declaration, another is called two type of declaration is here. Just see here, two type of declaration is here. One is called literal declaration, dynamic declaration. Now the question is whether both are object or one object, one variable. If you see, this is looking like a variable and this is looking like an object. Question is whether both is object or only the second one is object or first one is variable, right? What is the correct answer? Whether both object or only one object. So you may, if you see this, I'm saying that this is a separate name. It's called string literals. So string literals, when you got this name string literals, that means the declaration is like this. You have to remember that string literals are also object in Java. They are not variable. The string literals are also object in Java. They are not variable. This is object, very easy to understand from this syntax. Yes, it is creating an object for the immediate class string. But the string literals are also object in Java. They are not variable. Fine. Now the question is, if I am going to create a string, then which approach I'll use? I'll create string literals or I'll create dynamic declaration. Which option is best? Because both the way you can declare a string. So now the question is why they have used these two types of declaration of a string. Now if they have given two types of declaration of a string, then which one will be the best to use? Which type of string I'll create? So these are some of the questions come into picture, right? So let's talk about it. We have string literals and dynamic declaration. Best option when you create a particular string, always go for string literals. not for dynamic declaration. This is the recommended. Now you'll see that why I should go for string literals always. Why not for dynamic type of declaration of a string? What is the difference? Why they came with a separate string type object, right? So let's talk about it. First point is that string, when you create an object, if you remember, we talked about two things in JVM. One is stack, another is heap area. One is called stack area. You remember in JVM, stack area contain all the variable we create in the stack area, and on the object reference, object reference will come under stack area, and heap area contain all object declaration will come inside heap area. This is the thing, right? Now inside heap area, they have one location. It is called string constant pool inside heap area. Okay, inside heap area we have one location. Name of the location is string constant pool. Inside heap area there is a location called string constant pool. This string literals actually created inside string constant pool is created inside string constant pool. It is also a particular location inside heap. Fine, but dynamically created object, it is created inside heap area. But for string literals, there is a separate location inside heap area that is called string constant pool. And the question is why they have created a separate location for string literals in a string constant pool, and any normal string object is created inside in a heap area. Why this type of scenario? Correct. So let's explore it here. Let's talk about it first. So when you create any string literals, that string literals came into string constant pool. Okay, so I'm talking about string literals now. String literals. These string literals came into string constant pool, created inside a string constant pool. So how it is, just see here, I'm writing here string s1 equal to hello. Fine. So this object created in the string constant pool. So if it is created in the string constant pool, that means s1, it has some own, it's created in the stack area, it has some address 1 2 3 4, and this one is pointing to an object in a string constant pool. Object name is hello, and this hello has a particular address. Assume it is this. Fine. Now this s1 is pointing out to this object when s1 will contain this address 5555. Then we say that s1 reference is pointing out to this object hello in the string constant pool. Fine. Okay. Now next what we will do, once again I'm going to create an hello. Just see here please. It is done. Second time in my program, once again I'm going to create an hello. The string is 2, this time s2. Okay, s2 equal to, I'm going to create hello once again. So what will happen? Second time, if I'm going to create hello, what will happen? It will create an s2. It will create s2, and s2 has its own address. Second time, so whether it is going to create once again object? No, it is not going to get once again object. What it will do, it will check whether, in case of string literals, it will check whether this hello object already available in the string constant pool or not. This is the first line. Second time, when I'm going to get hello object once again, it will check whether this hello object already there in the string constant pool or not. Yes, it is already there in string constant pool, right? So what it will do, it will just map this object. It will just map, what is the address? 5555. It will just map this object with this, right? It will just map this object with this. That's it. So that is the thing. If the object is already there in the heap, hello is already there in the string constant pool. It is already there. So when I'm going to create the same object second time, it will check whether this object is there or not. Yes, it is there. Then this will map by s2. So whether you are going to get a new object? No. If the object is already there, it is not going to create a new object. In case of a string constant pool, if an object already available in the string constant pool, will not create a second object. It will map the same object. That's it. Object is already available in the string constant pool. It will map the same object. It is not going to create a new object. Now the question is that how you can say that? Yes, I'm just saying theoretically. You have to prove that yes, it is correct. How you can say that yes, it is not? It's pointing to the second object, right? That we can show writing a program like we have written this one. Writing a program, we have one of the operator called equal to operator. We have one of the operator called equal to operator. Equal to operator is used to check the object address. Okay, we have one of the operator called equal to operator. This is equal to. Okay, equal to operator is used to compare. It is used to compare object address in the heap. Okay, so it is used to compare object address in the heap. Let me check. So I can use here like if s1 equal to s2, both the object address is same, right? Then it will print same object address. System dot out dot println same object address, right? Else it will print different object address. System dot out dot println different object address, right? So let me check what is printing. Let me check what is printing. So Control C, and you're opening this, right? Okay, close this and get one class. Right click, new class. Name of the class is string demo. Fine. So just see here, Control V. Right, save it. Let me execute. What is the output? Right click, run a Java application. Just see here, same object address. So S1 and S2 pointing to same object address, right? S1, because this object already created in the heap first time. Second time, if you are going to get the same object, it is not creating a same object. It is going to point to the same object itself. So that is the property of a string constant pool. So if I'm going to use a string constant pool, if the object is already available in the heap, then it is not going to get a new object, right? But the scenario is not same for dynamically created object. This is what for a string constant pool. But what will happen in case of dynamically created object? Dynamically created object, what will happen? String dynamic object creation, correct? What will happen for string dynamic object creation? Save it. Let me check. So assume I'm creating the first object, string s1 equal to new string, and my string object name is hello. Dynamic object creation, right? Fine. So Control C copy and Control V. I'm getting another one object s2. Now see, two times I'm getting the same object, but what will happen in this case? It is a dynamic object creation. It is not getting in a string constant pool. So that theory will not be applicable for this. So what will happen? Just see here, please. First is S1. S1 has some address, assume 1, 2, 3, 4. And this S1 is going to point to a particular object inside a heap. What is the name of the object? New string. This is the name. This is the name of the object, right? Hello. Right? And this object has a particular address like this, right? And this S1 is pointing out to this object. How? It should contain this object address. That means it should contain 7777. That like this way S1 will point out this object. Fine. Now I've created another one object S2, same object I have created. Correct. So assume I'm taking S2. S2. So that also has a particular address. Assume this. Sorry. Assume this. Now this S2, second time, it is going to get the same object, right? But it will allocate resource from the heap. New string hello. Fine. It is creating, see, another object is going to create. That string constant pool theory will not work for this. It is going to create another object. So if it is going to create another object, it has some address. Assume this one. That means S2 is going to point. S2 is going to point 8888. Right? Right? So this is the thing. In case of dynamic object creation, if you create 10 object, same object, it will create 10 object in the heap. It will create 10 object in the heap. Though you're getting same object, you'll get 10 object in the heap. In case of string constant pool, if you're getting the same object, then second time it is not going to get the same object. It's going to point the existing object. But in case of dynamically object creation, every time it is creating a new object, though the string is same. So now how to prove it? So let us prove it. Yes, it's correct. Let us prove it. So what we'll do, the same things we'll write. We'll write a program and we'll see that whether it is correct or not. Fine. So whether it is correct or not, I'm going to prove. Control V. So this is S1. This is S2. Control C, Control V. The program, Control V. Now this string object is there. Now what I'm using equal to operator. So if both the object address is same, return true. If both the object address is different, it will return different object address. Correct? Fine. So let me check what it is giving. Control C. Let me disable the last code. Let me disable the last code. Control V. Save it. Fine. Right click, source, format. Yes. So this is my code now. Okay. Save it. And right click, run as Java application. See here what it is giving. Different object address. Now, in case of dynamically created object, both the object address is different. It is coming inside this. Right? So we can show, right, the difference between dynamically created object and string literals. So whatever I'm saying, we have shown using a program, right? So here, so out of these two types of object, which object we should create? We should always create string literals. So advantage is that same object, if I'm going to create, it is not going to create a new object. It will just point out to the existing object. So from that point of view, this string literals concept they came, that will be created in the separate location called string constant pool. And this is the important features for a string literal. That's why if I'm going to create a string in Java, best option to go for string literals always. Fine. Yes, please. Anyone want to add something more? Okay. So next for string, we have some string manipulation function. We can get a string array also, but I've already shown you how to get a string array last time. We have some string manipulation function. A string manipulation function. So this string manipulation function are nothing but when you're working on a string, then you are going to interact with some string provided function. So how to work with those functions, right? So related to that, let me show you some function. Like I have a string s1 equal to, writing on a string like this is a good book. Sorry, this is a good book. I've written one string here. Fine. Okay. Now what I want is first point is s1 dot to upper use s1.2 uppercase. Come inside a string s2 equal to s1.2 uppercase. Then string s3 equal to s1.2 lower case. So uppercase means the complete string will come into character and uppercase. I'm just printing SO means system.out.println s2 I can print. When it come in the lower case, then I'm going to print s3. Fine. Okay. Now here I can write another string s4. Now we have different function is there. S1 dot can use some called index of. So index of means position of a particular character is okay. Return. Then I have to print that s4. Right now here I'll tell you now. Similarly, I can use a string s5 s1 dot caret. You find this function if you go to the API documentation. You'll find these functions are there in position 5 or 6. Then I'm going to print system.out.println s5. Right. Then I'm going to print a string s6 equal to s1 dot let me last index of one method is there for s. And I'm going to print s6. I've written something wrong. I'm coming into that. Next, you can use some function string s7 equal to s1 dot substring make it 6 and print 7. Similarly, you can use string s8 equal to s1 dot substring 4 comma 7 and SOP right s8 like this, right? So what we have done, we have used different I've written something wrong. All are not correct. I've just written something wrong that we'll resolve now. What we have written is that I have written different string manipulation functions. How can use these different functions? If you go to the API documentation, you'll get these functions. Lots of other function is also there. I've used some of them. How to use them with the string related to that. Just see here. Control C copy. File new class. String manipulation function. Demo. Finish. Copy. Save. Now you can write here system.out.println. S2. Yes, we have some. I'm just resolving all the thing. Control C. Fine. Okay. Now here S1 I've written this is a good book, semicolon. Fine, no issues. Now S2 should come in uppercase. S3 should come in lowercase. Now in S4, what we have written, S1 dot index of S, position of S inside your string. So position of S is always int, not a string, right? So I have to use here int, right? Next, char at 6. That means in the 6th position, which character is there, right? So it is returning a character. Char at function is returning a character. So you cannot write a string here. You have to use char. Right? Same like last index of S means from the end. If I'm going with, then what is the position of S? The position of S, right? So it is a position of S, right? So it is returning an int, so not a string, int. Save it. And substring should return. Now everything is correct. Let me check it is running or not. Right click, run as Java application. You can see here uppercase, lowercase. Index of S is 3. 0, 1, 2, 3 will start from 0 position. And at the 6th position we have S, right? And then index of S is 6. Last index of S. Just think 6. And here I'm going to get substring. So from the 6th position, you'll get the substring, and this substring will get the string from 4 to 7. So this is how we can use different string manipulation function that we have, Now, when you work on a string, you'll find some. So string is a class in Java, and this string class is immutable. You can use a string, but except a string, there is some other one class called a string buffer. Okay, a string buffer and a string builder. To some extent, same. As what are the things you are doing in a string, those things we can do with a string buffer and a string builder class also. Okay. So now the question is why they have introduced these two types of class, string buffer, string builder. If I want to create a string object, I can use a string object. Now they came with a solution called string buffer and string builder. String buffer was already there earlier. The string builder came from Java 1.5 version. Though, so already we can use a string to create a string, manipulate a string. You can use string literals or dynamically create a string object. Question is that why they have came with this solution, string buffer and string builder, right? So first difference between string buffer and string builder is that it is immutable and it is mutable. Mutable means if you have created a string buffer object or a string builder object, and if you are going to change that object, you are going to change that existing object only. Every time it is not going to create a new object. No. Whereas string is immutable. Every time it is going to create a new object. But string buffer or string builder is mutable. Means if you create a string buffer object and if you change that object, you're not going to get a new object, you're going to change that existing object only. Okay, this is one major difference between them, but we should know how string buffer we can create. Okay, so let's see how we can create a string buffer. If you want to see this string buffer have different constructor inside API documentation. Go to the lang package, java.lang package. Go to java.lang package, and here you'll find a string and a string buffer both. String and string buffer. See here. So if you go inside this string buffer class, you'll find different constructor is there for a string buffer. Right? This constructor used a lot. This initially that string with default constructor, int capacity, and string buffer with string. This three is used a lot. Let me talk about this three constructor in a string buffer. Okay. So for a string buffer, we have these three constructor. String buffer. For a string buffer, we have three constructor is there. Control C. One is called string buffer with default constructor. Another is string buffer with int. Another is string buffer with string. Okay. These three constructor is there for a string buffer. Now why I'm saying that, because we'll see now only we'll see one of the important features of a string buffer. Very important features of a string buffer, why we are going to use it in our program. So just see here, I'm going to create an object using a string buffer, using this. First object, string buffer SB equal to new string buffer, correct? And I'm going to print system dot out dot println SB dot length and control C, control V, SB dot capacity. Okay. Now the second case, I'm using parameterized int. So I'm getting a string buffer with int. Assume its name is SB1. So I'm going to print SB1 dot length, SB1 dot capacity. And next, the third scenario, I'm going to use a string buffer with a string. Okay, take on a string, hello. Okay, and assume the object name is SB2. So I can write here SB2 dot length, SB2 dot capacity, right? Now, why I have given this scenario, if you execute this output, just see what is the output, just execute, check. Control C, copy. So we have to create one class called string buffer demo. string buffer demo. And inside this string buffer demo, just see here, save it, right click, source format, save this. Now if you execute, you can see the output. See here, the length is 0, capacity is 16. Just see this output. In the second scenario, length is 0, capacity is 10. Third scenario, length is 5, capacity is 21. See, this is the output. We should know why this output is coming like this, right? First output is 0 and 16. This output will find this is 0 and this is 16. What does it mean? The meaning is that when you create a string buffer object using default constructor, a string buffer object with default constructor, in string buffer there is a concept of capacity. I told you the difference between length and capacity. Inside a class, you have total 50 chairs, right? Out of these 50 chairs, only 10 students present, right? That means 40 chair is vacant. That means what is the length? Length is 10. But what is the capacity inside a classroom? That is 50. This is the difference between length and capacity. So when you create a string buffer object, this string buffer object is created string buffer object created if you see this, I'm just let's show you that how it is. It will create an array of object. It will create an array of object of length, array of object of it will start from this is the 0 location, 0 to 15. Assume the last room is this. So this string buffer object, it will create an array of object of length 15. Yes, tell me. When you're creating a first five room hello string came, and then after that it is going to add a default capacity of 16. That is 0 to 15. First it will add this 5 character hello, then after that is going to add default capacity of 16. Okay, so total number of room 21, 16 plus 5, but how many characters is available? 5. So length is 5, right? So this is about the third constructor with string, right? Okay, so fine. So this string buffer, now the thing is that you will say that why they have implemented this type of concept is that the reason is that sometimes we don't know how many characters coming from the other side, right? So what it will do, if you are going to work with a string buffer object, it has already room is ready. Okay, so you will the object will come and you can keep it here. As for example, if the room is filled up with a student, and another student came. So what he has to do, he has to bring the chair from the next room and then he'll sit. So it will take some time to bring the chair from the next room, right? Same like that. In the string buffer, already the chair is there. Chair means the room is already there. So the object will come and it will sit. So you don't have to create the object during runtime. Okay, it is already there. The object will come and sit. So that's why, using a string buffer, the data it will much more faster. All right, during runtime, you don't have to create that. The room is there, the object will come and you can allocate the room for the object because it has a default capacity of 16. In case of string as an argument, in case of zero argument, it has a default capacity of 16. In case of int argument, it has a default capacity of 10. Means that I can create a string buffer object with a default capacity of 10, or you can create a default capacity of 9, 5, 20 as you want. If you are going to use int as an argument inside your string buffer constructor, you'll create a default capacity of that much based on your requirement, right? So this is all about the string buffer you find. So now here you'll find another one class, that is string builder. String builder, you'll find another one class, string builder. String builder, this is also same like string buffer. In the string buffer you find these constructors, right? In string builder also you have the same constructor. Whatever the properties just now we talk about string buffer, all the properties are same for string buffer, string builder also. Okay, so the point difference is that the difference between string buffer and string builder is where that this string builder, it came from Java 1.5 version. It was from earlier. Now difference is that this string buffer, it is string buffer, it is synchronized. Synchronized means since string buffer is synchronized means already talked about, right? If multiple request is coming, if multiple thread request is coming, then at a time only one thread can access that request and other thread have to wait in the queue. So this process is called thread synchronization. So string buffer is synchronized. So if you are going to use string buffer, then thread application is the best one to use string buffer. But if it is not thread application, then go for a string builder. If it is not a thread application, go for a string builder because it is not synchronized. So if you are not using a thread application, if you are not using a thread application, then better to go for a string builder. If you're not using thread application, better to go for a string builder. Fine. If you're using a thread application, then better to go for a string buffer because string builder is not synchronized. Since it is not synchronized, then string builder is much more faster than a string buffer. Okay. So this is the thing. Yes, please. Anyone want to add something more? I can tell.